Hi everyone, welcome to Learning Math with VK. Today we explore lesson 15 in algebra, polynomial function and the rational zero or root theorem. Number one, polynomial function. A polynomial function in terms of x has the form f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0. A sub n times x to the n, we call it the leading term. A sub 0, we call it the constant term. In the leading term, the number a sub n, we call it the leading coefficient. And the number n, we call it the degree of a polynomial. N is a positive integer. A sub 0, a sub 1, a sub 2, all the way up to a sub n. They are real number. When we set fx equal to 0, then solution to this polynomial equation, or call it 0 or root of the polynomial function, the rational zero or root theorem is very useful in factoring polynomial. A rational zero or root of a polynomial function with integer coefficient has the form p over q, where p is an integer factor of the constant term, q is an integer factor of the leading coefficient. Let's prove it. Let fx equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0, where a sub 0, a sub 1 a sub n are integer. We assume p over q is a 0 or root of f. Well, if p over q is the 0 or root of f, then we have to simplify this fraction, meaning that we also assume that the greatest common factor of p and q is 1. Then can do the substitution. F of p over q now, it is a 0 root, so it should be 0. P over q is equal to 0. Now work it out. F of p over q is the a sub n p over q to the n plus a sub n minus 1 p over q n minus 1 plus plus a sub 2 p over q to the power 2 plus a sub 1 p over q plus a sub 0. is equal to 0. From here, we can multiply both sides by q to the n and get rid of the fraction. Do this, and we have a sub n p to the n plus a sub n minus 1 p to the n minus 1 q plus dot 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 plus a sub 2 p square qn minus 2 plus a sub 1 p qn minus 1 plus a sub 0 q to the n equal to 0. This is what we can do next. We can minus a sub 0 qn to the side. Minus a sub 0 qn minus a sub 0 qn. This is gone. Notice that we can factor out a p from this linear combination. Factor the p, then we get a sub n pn minus 1 plus a sub n minus 1 pn minus 2 q plus dot 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 plus a sub 2 pqn minus 2 plus a sub 1 qn minus 1. Okay. And this would equal to minus a sub 0 qn. So here come the glory part. P and Q, the GCF of P and Q is 1. Since GCF the greatest common factor, P and Q is 1. The greatest common factor of P and Q to the n is also 1. This means that a sub 0 is a multiple of P and some number alpha. So P is the factor of a sub 0. Similarly, I'm going to use the equation storer here. We're going to take a look at it by subtracting a sub n p to the power n on both sides. This is gone. Similarly, we're going to take out a q from the remaining terms. Factor a q, and we have an minus 1, pn minus 1, plus dot dot dot, plus a sub 2, p square qn minus 3, plus a sub 1, pqn minus 2, plus a sub 0, qn minus 1. So this is equal to negative a sub n, p to the n. Using a similar argument, since the GCF of P and Q equal 1, the GCF of P to the n and Q is also 1. This tells us that a sub n must be a multiple of Q. So Q beta. Q is a factor of a sub n. And this complete the proof. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.